Good morning, good evening, good very early morning, good afternoon. Welcome, welcome, welcome. I hope everyone is doing well on this lovely January, very early in the morning for the East Coast. What we're doing today is we're going to watch United Launch Alliance on its maiden voyage of the Vulcan Centaur. This is part of a certification flight for the Vulcan. It is also taking a payload. So it's taking a couple of very special things on the payload. One of which is going to be the return to the moon. Um, it's going to take a small robotic payload to the moon for help with future Artemis missions and for future manned missions that may land on the moon. Um, Curiously, we have also on the 9th, which is technically tomorrow, but it's 2 days from now, because I plan to get some sleep after this. it's NASA's going to hold a press conference on Artemis 2, probably depending on the results of this flight. And that is going to be information on what and when to expect the Artemis 2 mission, which is humans' return to the moon. So, this is the United Launch Alliance. So, this is a joint venture between Boeing and some of the other defense contractors. Boeing and Lockheed are the two major contributors to this specific flight in this specific company. So it's a joint venture that they got together to put together this vehicle. We all know that Boeing is had some problems in the aerospace in the flight aerospace sector recently. I'm not a massive fan of Boeing aerospace or Boeing rocketry or Boeing anything. Um, But the one thing I will give them is that the Centaur upper stage with the RL-10 engines have been incredibly reliable and are reflight. So we'll get into the rocket design and kind of that sort of thing as we get going here. Um, so we'll get into that kind of thing. But let's say hello to everybody real quick, and we'll get right into it. Dog Mama, hello. Bad Daza, hello. 85%, yeah. Yep. Hey, what's up, Scad? HT, hello. Shanny, hello. Boeing did build this, yes. So let's take a look at weather from the 45th Space Force, Space Weather Wing. And like Scad said, we have an 85% chance of launch when it comes to weather. We have a 15% probability of violating weather constraints, and that is the thick clouds rule. If you joined us for the earlier SpaceX flight, it was the same rule that we had concerns about violating. And that one went off without a hitch. I will tell you that given this is a test flight and given this is not SpaceX, then it could be they're a little bit more cautious. But everything I've seen going so far is that we're good for flight. So hopefully we get to see flight this evening because the weather constraints get worse and worse as we continue on. So we're going to go over here to ULA, or the United Launch Alliance, and we're going to go down here to the mission overview. United Launch Alliance Vulcan VC-2S rocket will launch the first certification mission from SLC-41 at Cape Canaveral Space Force Station in Florida. So that's a certification mission, and it will have the astrobotic Peregrine commercial lander in a highly elliptical orbit of more than 220,000 miles or 360,000 kilometers above Earth to intercept the moon, and will carry the Celestis Memorial Spaceflight payload into deep space. Has a couple other things on it. It has two Amazon broadband internet satellites as well. So it'll be a multi-stage, multi-mission effort. this is what our flight profile kind of looks like. We're going to get a similar right, but we're going to get much higher. Um, so T minus 4.9 seconds, we get BE4 engine ignition. Liftoff at 1.1 seconds. So that's after the engine's burning, after we get to the T minus time, 1.1 seconds into flight, we should start seeing a liftoff of this rocket. Pitch yaw would be 7.9 seconds into flight. Mach 1 will be 1.9 or 1 minute and 9 seconds into flight. And our max Q, or maximum dynamic pressure, will be T plus 1 minute 16 seconds. There are 2 strap-on solid rocket booster engines on this specific configuration of the rocket. Those SRBs will jettison at T plus 1 minute and 50 seconds. And then we go about 3 minutes and 8 seconds, and then we'll get booster engine cutoff. That's similar to SpaceX's main engine cutoff. Booster will separate from Centaur about 7 seconds, 6 seconds after that. And then it will coast for about 9 seconds, and the Centaur main engine start. Those 2 RL-10 engines will start at T plus 5 minutes and 14 seconds. Just looking at the pad right now, because ULA builds in holds, and they can be deceptive sometimes. So ULA has the countdown clock at T minus 7 minutes right now. But we know that they're in a hold, and that hold is generally about 15 minutes. So, yeah. And then there's several other different flights and different firings of the Centaur engines. So basically what this is doing is this is going to wrap around Earth. It's going to use Earth as gravity assist. Then as we get to this 10, they're going to hit the gas, burn all the way to here, should be. And that will take it in a very high orbit that will wrap around the moon. Then they'll ditch the payload on the moon or in the moon's orbit, and then the rocket will continue back to Earth. So this is kind of what we have here. We have a 5.4 meter payload fairing, a payload adapter. The Peregrine spacecraft is on top of that adapter. Launch vehicle adapter Centaur, and these are reliable Centaur stage with the RL-10 engines. We have the interstage adapter. Then we have our booster with our 2 strap-on solid rocket boosters. And then we have the BE4. We have a pair of BE4 engines as the base. This gives you some idea of how their process is. They have solid rocket boosters. The booster comes in, interstage adapter. They all go into this building. And then the payload and spacecraft come in, and then they're stacked on top. It rolls out to the pad, and then it launches. They like to talk about how many states are involved in their process. So the BE4 engines are made by Amazon. They are made by, Bezos, Amazon. They're made by what's their name? I'm trying to remember what their name is, but I can't right off the top of my head. The same ones that do New Shepard and New Glenn. Blue Origin, excuse me. In Utah, the solid rocket boosters are made by Northrop Grumman. Denver, Colorado is the design headquarters. Booster fabrication, final assembly, Centaur tank, and final assembly of that is in Decatur, Alabama, where much of our rocket history comes from here. The fairing and fabrication beyond gravity is also in Decatur, Alabama, and the RL-10Cs are made by Rocketdyne in sunny Florida. So that's how we kind of break down. Rocketdyne is incredibly respected in aerospace, and they're usually pretty reliable. Rocketdyne is the same ones that built the F1 engines for the Saturn V. So we're going to take a look real quick at the mission profile from NASA. This is kind of their advertisement for the week, and we'll check this out real quick.
The first Artemis robotic launch to the moon, an Artemis lunar robotic rover is halfway built, and an up-close look at a volcanic moon. A few of the stories to tell you about this week at NASA. United Launch Alliance and Astrobotic are currently targeting no earlier than January 8th for the launch of Astrobotic's Peregrine lunar lander to the moon. NASA payloads aboard the lander aim to help the agency develop capabilities needed to explore the moon under Artemis. This is the first commercial robotic launch to the moon's surface as part of our CLIPS initiative and Artemis program.
So that is all that we need out of that specific clip. That is the mission profile. That is kind of what's going on with this mission. It's going to support, do all those different things. Next, we'll go over to the. Nope, that is the correct one. The overview of the Vulcan Centaur from United Launch Alliance, and see a little bit about how they've got here and what they've done. So, if I switch it over, that would be awesome.
Vulcan Centaur production begins with aluminum sheets, expertly machined to remove more than 2/3 of the weight, resulting in the structurally strong yet lightweight orthogrid panels that form Vulcan's propellant tanks. The panels are then bump pressed to form the curves required to complete the tanks. At the same time, rings, adapters, and other structural components are precision milled.
Hey, Linda.
Next, the aluminum domes, panels, and other structures that form Vulcan's propellant tanks are first cleaned and etched to a smooth, even surface, and then anodized to harden and prevent corrosion. Following an ultrasonic inspection, 5 completed panels for the liquid methane tank are assembled and joined together using friction stir welding. Unlike traditional welding, where filler material is used to join components, friction stir welding uses a head to stir the metal of the 2 panels together as it moves down the seam. The resulting joint is stronger and produces a lighter weight, higher performing tank. The process is repeated to create the liquid oxygen, or LOX tank, followed by attaching domes to complete the tanks. Circumferential friction stir welding is then used to join the 2 propellant tanks that comprise the Vulcan booster. As production continues on the booster stage, stretch-forming gore panels for the Centaur's second stage propellant tanks is underway. The stainless steel gore panels are welded together to create the propellant tank domes. The gore welder is one of several highly specialized welding stations in the Centaur production process. Just down the aisle, Centaur V's massive intermediate bulkhead is mated to its ultra-thin tank. Once both propellant tanks are welded, they're mated together to create the Centaur V second stage. Before moving to final assembly, the 5.4-meter booster welds are sprayed with foam insulation, followed by booster mask and paint. Twin BE4 engines are individually hot-fired prior to making their way to the factory. They are then mated to Vulcan's thrust structure and protected by a heat shield. With production complete, Vulcan's first and second stages depart the Decatur factory and make their way to ULA's rocket ship to begin their journey to the launch site. Meanwhile, at Cape Canaveral's Space Launch Complex 41, modifications have been made to the launch pad to accommodate the Vulcan rocket. The water suppression system has been upgraded and tested, along with other updates, including new, larger fuel storage tanks. Additionally, in the Vertical Integration Facility, or VIF, platforms have been modified to accommodate this larger vehicle. Following the journey to Cape Canaveral, the Vulcan components are offloaded from rocket ship and transported to the VIF, where they are lifted onto the newly constructed Vulcan Launch Platform, or VLP. The vehicle then travels 1/3 of a mile to the pad to fill both propellant tanks, followed by flight readiness firing of the booster stage.
So that is ULA's new shiny toy. So a couple of the downsides about this specific vehicle. Um, one of which, um, it has been delayed a ton, a ton, a ton, a ton. So this was originally supposed to launch in June of 2022. It was then delayed to August of 2022. It was then delayed again to February of 2023. It was then delayed again until May 4th of 2023, and then again till December 24th of 2023. And this is the first time that it's been on the pad and ready to go. So, like anything else, quite a bit of delays. Again, we don't see that with some of the ones that we love, and I hate just continuously referencing SpaceX, but they do it different. They do it different. It is considerably different. And it's something that everybody should strive for because they're the best game in town. They are. They may have a day or two delay, but it's never anything like this. It's never where it's delayed and delayed and delayed and delayed for years. This is 2 years past when it was supposed to launch. So just keep that in mind. So this is their hype video that they put out this morning. It's about 20 seconds long, and this is pretty much their hype video about Centaur. So as you saw, they got rid of one of my favorite and most iconic rockets, and the only thing I really still liked from Boeing. So that's kind of frustrating. The Vulcan Centaur replaced the Delta IV Heavy. The Delta IV Heavy is the only, and I don't know if I've ever showed everybody, but I have a shelf with various different rockets in it that I enjoy, that I've either printed or purchased models of, or stuff like that. And there's several rockets in there. Everything from a Saturn to a Falcon to various versions of the Starship, things of that nature. And the other one that I have from Boeing is the Delta IV Heavy. The Delta IV Heavy is what was replaced with this Vulcan Centaur. The Delta IV Heavy was the 3 boosters side by side, much like a Falcon Heavy. But part of the design was that there was a big fireball, and they tend to launch them at night, which was really cool. And actually the flames would go up the outside of the vehicle, and it would burn off the paint on the vehicle. And it was designed that way, but it was a really cool spaceflight thing. Oh, I don't doubt it. There's a lot of money riding on this, and NASA really needs this to work. So that's one of the ones that I really did enjoy was the Delta IV Heavy, and this effectively retired that. So we're gonna try and get in this one last video. This is the mission profile for tonight's mission, and then by then hopefully we're catching them out of the hold just in time.
Following final confirmation of rocket and payload readiness, two GEM 63XL solid rocket boosters and twin BE-4 engines produce more than 1.7 million pounds of thrust to lift ULA's Vulcan rocket away from Cape Canaveral's Space Launch Complex 41. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Vulcan then reaches Mach 1, the speed of sound. With the ability to add 2, 4, or 6 solid rocket boosters, or SRBs, Vulcan can be precisely configured to take any mission to space, from low Earth orbit to Pluto and beyond. These boosters augment the rocket's total thrust at liftoff, adding approximately 460,000 pounds of thrust per SRB. With their propellant expired approximately 90 seconds into ascent, the SRBs burn out, followed by jettison. Jettison time is variable, occurring between 100 and 150 seconds after liftoff, depending on mission requirements. Vulcan's guidance system then activates to steer towards the precise target in space. First stage flight continues as the rocket crosses the Kármán line, entering space. With the majority of propellant expended as Vulcan fights against the force of gravity, the BE-4 engines shut down, and the booster stage separates. With the rocket now weighing less than 10% of what it did at liftoff, dual RL-10
systems propulsion. Go. Hydraulics. Go. Pneumatics.
We're going to go to the poll, the
Go.
go no go poll,
LO2. Go.
and
Water.
catch up on that because
Go.
it's important.
Centaur systems propulsion. Go. Pneumatics. Go. LO2. Go. LH2.
Go.
Has gas. Go. Electrical systems airborne.
Go.
Ground. Go. Facility. Go. RSFTS. Go. Flight control. Go. GC cubed.
Go.
Operation support. Go. COM. Go. Umbilicals. Go. ECS. Go. Red line monitor. Go. Quality. Go. Ops safety manager. Go. ULA safety officer. Go. Vehicle system engineer.
Go.
Anomaly chief. Go. Range coordinator. Clear to proceed. Launch director. You have permission to launch. Proceeding with the count.
All right,
Proceed.
so we are go for
Verify
launch. So we are.
set 407 18
So we're going to go back and finish up this video because we still have 7 minutes in the time.
SLC
or in the
engines on
countdown.
ULA's Centaur upper stage ignite. Spacecraft are encapsulated inside a 5.4-meter diameter payload fairing, which provides a protective environment during ascent. Following Centaur engine ignition, the payload fairing is jettisoned. With the first burn complete, the Centaur engine shuts down for a coast phase. Centaur flies a short, medium, or long coast, which is determined by launch day. Further into flight, Centaur ignites for a second burn, powering the vehicle into a translunar injection orbit. Following the second main engine cutoff, ULA Centaur places Astrobotic's Peregrine lunar lander into a highly elliptical orbit, more than 220,000 miles above Earth, where it will intercept the Moon. Following delivery of the Peregrine spacecraft, Centaur comes alive for a third and final burn to reach a heliocentric orbit around the Sun. Centaur completes the CERT-1 mission by carrying Celestis' Memorial spaceflight payload into deep space. Known as the Enterprise flight, this mission includes 234 flight capsules containing cremated remains, DNA samples, and messages of greetings from clients worldwide.
That's
on
really
an
cool.
endless journey in interplanetary space
That's what's good.
beyond
We
the
talked about
Earth-Moon
the
system
Enterprise, the
to orbit the Sun
Star Trek
forever.
ashes. So they're going to deorbit it so it can be in a parking orbit around the Sun, and
T-minus 7 minutes and holding. We anticipate
back over
releasing
here.
the hold in just a few moments.
so we'll wait till we see the clock count down. But so that was what Scad was telling me about, and it's the Enterprise portion of the mission, and it is. So I'll just read what it says. The Celestis mission will launch 265 flight capsules containing cremated remains, DNA, and messages of greetings from clients worldwide on an endless journey in interplanetary space and beyond the Earth-Moon system and the orbit the Sun forever. Aboard are the creator of the original Star Trek television series, Gene Roddenberry, his wife, Majel Barrett Roddenberry, and cast members Nichelle Nichols, the actress who plays Lieutenant Natoya Ura, and beloved actor James Scotty Doohan, who played the chief engineer of Starship Enterprise.
Vulcan rocket away from Cape Canaveral Space Launch Complex 41. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight.
Okay, so they're just going to
Vulcan
replay
then
their
reaches Mach 1.
video again. So with that, again, they'll also have the Amazon Kuiper satellites. Amazon actually, and forgive me, I don't know if they actually did, because Amazon delayed them so many times it wasn't worth checking up on every day anymore. But these were supposed to be 3D printed engines, the BE4s from, I just keep calling them Amazon, but Blue Origin. So there's supposed to be a technology exchange between Blue Origin for their new Glenn and the Vulcan Centaur for the engines. So they were supposed to exchange technology and thoughts and stuff like that between the two of them. And it was supposed to be a partnership that went beyond. So that's another thing that really plays into that. So I know Scotty's dead. Could Bones not make him better? I have no idea what that means. You know, I don't watch movies or television. So we're looking at the animation once again from ULA with the Vulcan Centaur. So the Vulcan is the bottom portion of the rocket. You can think of it like the booster that returns to Earth for SpaceX. And the top portion of the rocket is the Centaur. Again, the Centaur has been tested. It is a very, very clean, very good design. It's kind of legacy tech, but legacy tech that works. And again, it has the Rocketdyne RL10 engines. Rocketdyne has always been very reliable. So with that, there's going to be a couple things, because this is a test flight for all intents and purposes. This is a certification flight so that it can continue to advance. There is big concerns with those BE4 engines. Now, obviously, they've been tested, but this will be their first flight off planet. It's a different system to test them in a test setting and to have them carry a payload off Earth. So you even know Star Trek. I just don't. I've never been one to get into it. Don't say it. Don't even think it. I'm not thinking anything. I'm just stating what the possible concerns could be. So this uses like
FTS internal.
this uses liquid hydrogen, liquid oxygen. So they pretty much the simplest fuels, but
238.
really effective. They're flight proven. That's what NASA uses.
CLO2 PLP started.
Unfortunately, since it's a new rocket, I don't know the callouts as well as I do other programs or where we're headed. So we're kind of watching this one together. You can see the frost ring on the outside. That's because both the fuel and the oxidizer are super cooled. You can see the hydrogen burn off. So that's probably part of the recondenser burning off the hydrogen.
Internal. T-minus 2
155.
minutes. The launch vehicle, payload, ground systems, and eastern range are go for launch.
We are
For
still
those of
go.
you just joining, I'm Amanda Sterling, and I'm your host for today's live coverage of the inaugural Vulcan rocket launch. The team is not working any issues, and we're on track for an on-time liftoff at 2:18:38 a.m. Eastern Time.
No spoilers, Scad. Uh, so another interesting thing with this is none of this will be recovered. None of this is reusable.
120.
The strap-on boosters are not recoverable or reusable,
Count started.
and the main stage is not recoverable and not reusable. These are all expendable, with no intentions of ever being so.
One minute.
T-minus 1
T
minute,
minus 1 minute.
Range status.
Range green.
and we're green on range. It's a good call out. So that means we're still proceeding with count.
45.
Vulcan tanks at step 3.
T-minus 30.
Start box. Go. Status check.
Go Vulcan.
Go Centaur. Go Peregrine.
Go ULA, go Vulcan, go Centaur.
10.
T minus 10.
T-minus 10.
9, 8, 7, 6, 5, 4, 3. We have ignition. And liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in spaceflight to the moon and beyond.
Engines operating. 2 good SRBs, hitting peak pressure on the SRBs.
That kind of slid off to the offside. That was different.
We've got pitch and yaw programs in, coming into normal rates for that event. We have good hydraulic pressure on both engines. Good chamber pressure on both engines, everything looking good. Coming up on 60 seconds into the flight, everything looking good. 2 good engines, 2 good SRBs. Body rates look good, nice and smooth. And we've hit our first throttle point on the BE4s, everything looking good. And we have passed through Mach 1, we are now supersonic, coming up on max Q. At max dynamic pressure, everything looking good. We're rolling off on the SRBs. And we have cutoff on the SRBs, coming up on jettison in approximately 30 seconds.
So the SRB stand
15
for
seconds,
solid
SRB
rocket
check,
boosters,
BE4s continue to operate nominally.
and they're a solid.
Seeing expected PU activity on the booster
They're a
range.
solid fuel that's highly stable until it's lit.
And we have separation of both SRBs, everything looking good. BE4s continue to operate normally.
And they can
Coming up on 2
they
minutes into
continue
the
to burn
mission.
until they burn out. So
We are
they're like
now
lighting a
17
candle.
miles
They
an hour.
continue.
We just heard
I mean, I guess you can
confirmation
turn
of
off a
solid
candle, but
rocket booster
you know what I'm saying.
jettison. We have about 3 minutes until we reach our next mission event, booster engine cutoff.
It will be
We see
sometime,
booster PU
probably.
correcting towards a nominal MR, everything looking good.
I can see stuff dropping off
Both
the rocket
engines
and falling back to
continue
Earth.
to burn
Yeah, they just jettisoned boosters. So the 2 solid rocket boosters were just jettisoned, and they will drop into the ocean.
And we now weigh approximately half of our liftoff weight. Everything looking good. And we fired the power valve, activating the reaction control system. On the upper stage, pressures are rising. As expected, PE4 continues to operate normally. Vehicles continue to fly down the center of the range track, everything looking good. 33 miles in altitude, 52 miles downrange, traveling at 4,000 miles per hour. Continue to see excellent performance out of the BE4s. Chamber pressure nice and smooth. Vehicle steadily accelerating, a little over 2 Gs at this time. Good body rates. Nice and smooth operation of the booster. 47 miles in altitude, 95 miles downrange at 5,500 miles per hour. Engines continue to burn normally. Everything looking good. And the vehicle now weighs 1/4 of its liftoff weight as we pass through the Kármán line. Next mark event we're looking for is boost phase chill down on the Centaur main engines. Booster mains continue to operate normally. And we've begun boost phase chill. Housing temps are dropping as expected. Coming up to the end of boost phase, approximately 10 seconds to BECO. Throttle down in preparation for BECO. We've completed boost phase chill down, and we have cutoff. Coming up on Vulcan Centaur separation. We have Vulcan Centaur separation. Everything looking good. Coming up on the Centaur phase. And experiencing a bit of data loss here. We've recovered the data. It's like Centaur engines are up and running normally, good steady state pressure, and we've just jettisoned the payload fairing. 2 good brake wires. And good steady state operating levels on the Centaur mains. 2 good engines. Gone to open loop control on Centaur PU.
This is Vulcan Mission Control at T plus 5 minutes 57 seconds. We just heard flight commentator Rob Gannon confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, main engine cutoff, will occur in about 10 minutes.
I knew
While we wait, I'm joined by Amanda Bicchetti, ULA Director of Vehicle Upgrades. Amanda, thank you so much for joining us, and I know it's
Okay, so we'll leave them for a second. So now that it is airborne, now that it has left our atmosphere, this is something that will continue to fly until about February 23rd is the anticipated touchdown date on the moon. So, a month and a half, somewhere in that vicinity. Well, it'll be about a month and a half, won't it? I'm looking at the date. So, about a month and a half that will take for it to reach the lunar surface. It will be the first commercial mission ever to land on the moon, and it will be the first NASA mission since Apollo 17 to land on the moon. So this was a huge achievement. We're not gonna belittle it at all. This was a huge achievement. This is the first commercial space mission to land on the moon. It is also the first one since Apollo 17. So it's the first time in 50 years that the United States has been back to the moon. Oh, good deal. And I'll definitely cover that when that. I am too. I absolutely am. So I'll definitely cover that if they're going to provide any video or telemetry or anything, basically for that. I'd be happy to cover it. But yeah, I mean, this was a successful mission and good for them. I mean, this video is fake. This is a what do they call that? You know what I mean? Yeah, I'm very jealous.
On 500 seconds into the mission, everything's looking good. Continuing to burn Centaur. Body rates look right as expected. Steady acceleration, just under half a G. And we are now 235 miles in altitude, 836 miles downrange, traveling at 11,150 miles per hour. Continue to see nominal performance from Centaur.
You thought you drove fast. Yeah, no, it's moving quick, and it's gonna. I mean, it will move even quicker.
Yeah, approaching the halfway point of this first burn of Centaur, everything looks good.
So without most of the rocket that you had to lift, without all the atmosphere, without all of those things,
1,000 miles downrange, traveling at 11,500 miles per hour.
you can pick up speed much quicker, obviously, than you can from Earth with much smaller engines. These RL-10s are vacuum optimized, just like the Merlin 1D. Say rocket launches and landings are the only perk of living here. It'd be worth it.
This is Vulcan Mission Control at T plus 10 minutes 7 seconds. Our next event, main engine cutoff, will occur in about 5 minutes. While we wait, I'm joined by Eric Monda, part of ULA's mission design team. Eric, thanks for joining us.
Hi, Amanda. Thank you for having me.
Of course. So we're still pretty early in this flight today, but can you tell us how the data is looking so far?
Yeah, absolutely. So I just want to say that it was so exciting. I ran outside so I could watch this thing lift off, and that was so cool after so many years of development to watch this thing fly. That was fantastic.
Absolutely, I bet.
Yeah.
So what is the data showing us so far?
Yeah, absolutely. So I've had a very quick look. Obviously, we're very early in the flight still, but I've taken a look at the SRB performance as well as the booster performance so far, and everything looks just spot on, just perfect. Fortunately, we've had a lot of these systems on Atlas and Delta for a long time, and so we've had a lot of flight data to anchor our models, and everything is lining up just like we would expect.
Awesome.
Yeah.
So a lot of the audience has seen us switch from this live view of the launch from our rocket cam to this animated
Does sound like a
representation
proud
of the
dad.
vehicle in space. Can you talk a little bit about why we make that switch and how this visual is populated?
Yeah, absolutely. So when we first lift off, we have a feed directly from the cameras that are on the rocket back to the launch site here. And so with that, we can get the video feed that we need in order to provide those images. As we get further downrange and we go over the horizon, we no longer have that direct link. And so we rely on NASA's teeter system to send telemetry from the vehicle back down to us on the ground. In that telemetry data, we get information like position and attitude and velocity. And so we use that to drive the animations you see here.
Okay, so we're looking at real data, what's happening. It's just a graphic of it instead of the real thing.
That's exactly right. Yes.
Awesome. That's really cool. So, today right now we're in the first of 3 Centaur burns. Can you talk a little bit about why we need 3 burns and how we use those 3 burns to complete our mission today?
Yeah, absolutely. So the first burn performs our injection into low Earth orbit. Unfortunately, if we just continue that burn from that point in time, we wouldn't necessarily be aligned with where we need to be in order to get to the moon. So what we do after we get to low Earth orbit is we shut those engines down, we coast around until we get to the right spot to do that, and then we light those engines up again. When we do that and complete that burn, that will allow us to send the astrobotic Peregrine lander onto the moon. So we shut those engines down again. We are ready to do that, and then start them up one more time in order to do the third burn. That's what's going to take Celestis's Enterprise mission out to deep space. So let's talk a little bit about where these things happen.
Mhm.
We're going to go ahead and shut down the main engines on the Centaur when we get about halfway across the Atlantic Ocean, and then we're going to coast the rest of the way across the Atlantic Ocean.
Hey, no
across
worries. I
Africa,
love doing it.
and go ahead and start
It's
the
fun.
engines up again when we get to Madagascar, and that's where we'll do the second burn, and then we coast again until we get about to Papua New Guinea. And when we get about to over Papua New Guinea, that's where we'll go ahead and do that third and final burn.
Okay, so you mentioned a couple of these key milestones that are ahead of us. What can everyone expect to see as far as the timeline of these mission events as they continue watching today?
Yeah, absolutely. So looking at the clock right now, looks like we've got about 2 minutes, a little over 2 minutes left here in the first burn of the upper stage. We're going to coast for about 30 minutes after that as we do that coast across the Atlantic Ocean and across Africa. The second burn will be about 4 minutes long, and then we'll have another coast for 30 minutes before we have a pretty short, like 20-second burn for the final burn. Once we've done that, then we've got some engineering demos we're going to do before we finally safe the stage and shut everything off. And then about 4 days later is when the Centaur will leave the Earth-Moon system and be off on its way to deep space.
Awesome. Well, thank you so much for sharing that with us, and thanks for joining us today. And we'll let you get back to watching those next events.
Absolutely. Thanks so much, Amanda.
Thanks.
And I was going to watch through the end of this orbital insertion burn so we get a good orbital insertion, a good parking orbit, and then
PU
cut the
system is
stream.
steadily making the correction down to a nominal MR.
Ooh, they're a little high. That's what that means. So their pitch is a little high.
Two or 1 minute, D'Amico. Both engines firing normally.
And the problem is if you get too high on your ellipse, then you're going to be way off. Your burns are going to be all off. And if you pitch down too quickly, then you're liable to lose the rocket. If you don't have enough time left in your burn to correct that additional height that you gained, then you could run out of fuel because then you're going to have to go retro. And that's why it's really such a precise thing. So
this is Vulcan Mission Control at T plus 15 minutes 30 seconds. We are approaching the first main engine cutoff. Let's listen in.
Coming up on MECO 1.
I want to hear the MECO cutoff, and then I'll
control MECO. We have cutoff. Both engines show normal shutdown signatures. We have settling established, 85% duty cycle. We are now in a 27-minute, 51-second coast duration to second burn of Centaur.
27 minutes, so they cut it down because it was
Vulcan Mission Control at T plus 16 minutes 20 seconds. We just heard flight commentator Rob Gannon confirm successful cutoff of the first main engine, and all systems continue to operate nominally.
So they're going to try and arrest it, and they cut that down because that first burn was supposed to be 31, just around 31 minutes, or the gap between the first burn. So they're cutting that down to 27 to try and circularize that. What could cause that to happen? Overperformance of the engine. There's a lot of things that could cause it to happen. Their pitch could have been off. Their modeling could have been off. It's the first flight of the rocket, so there's a lot of different things that could go wrong. I'm going to take it off this lady. There we go. So there's a lot of things that could happen in order to make that. It shouldn't be. I'm obviously not looking at telemetry data, but it should be something that, based on the way they were talking, they're confident they can fix or rectify. But it did appear that there was a concern. So could get lost in space. Well, I mean, theoretically, if you're too high, then the other side of that orbit could be too low, and you could come back to Earth and you could burn up. So, or exactly, you could, it's less likely that you're going to. It's less likely that you're going to just float off into space because of gravity. That would take a pretty big error. So it's more likely that, one, you would come back to Earth, or two, that you would potentially run out of fuel trying to course correct or trying to correct for the error. Because the further you get away from the error, the harder it is to correct for it. So those are the things. that are going on. Not that photo shows it, folks. That's the lingo. I missed what you said. But anyways, sure. So yeah, I know, Bobby. That's why I had to take it down. But yeah, from what we could see, it looks like a successful flight at this point. I will definitely be keeping an eye on it. See if I can't figure out what happened. There was a slight error. I don't think it's anything to get. I don't think it's anything to get terribly concerned about. But unless I see data, I wouldn't know. Because even officially, they're saying they're cutting down the. But yeah, overperformance is usually so, especially when you're using brand new rocket engines, um, brand new setups. You can sometimes get overperformance, and that puts your telemetry out of whack just briefly, and you basically have to go into that second burn or um, with this type of rocket based on separation. So you have to be able to separate from that first stage since the first stage is continuing to follow. So you have to burn immediately out. So that's one of the things that it could have potentially been as well. But, ladies and gentlemen, that is going to be it for me this evening. We were supposed to tomorrow. We're supposed to have another Starlink mission. And hopefully you're in for a late night tomorrow because we have another late one coming up. We have the Chinese space program with their Long March 2C with their Einstein satellite. So they're running an Einstein satellite. Should be tomorrow. It's scheduled for 2:20 a.m. So about the same time that the Centaur went off tonight. And it's scheduled for tomorrow. So that's what we have on the docket tomorrow. A Starlink 710 at about midnight Eastern, somewhere between midnight and 2:30. And we'll also have the Chinese space program with the Einstein probe at 2:20 is anticipated liftoff. So, as always, thank you so much for watching. If you just go back and watch it, go back and watch it. I'm sorry, buddy. Yes, yes. But yeah, we'll see what we can't get tomorrow. Like I said, the Long March Chinese space program, that's an interesting mission as well. So I hope everybody has a wonderful evening, and I will catch you again very soon. Take care, everybody.